Hi, on behalf of 24 Hour Answers team, I would like to welcome you to today's lesson. Today's lesson is electrostatic potential. In our previous lessons, we have covered electric field and electric force. Now we move on to another important subject, electric potential. If you remember, we said that every electric charge creates an electric field around it, and that field is a region within which the charge can exert its electrostatic influence. Electrostatic influence is the electric force with which one charge influences the other. Let's say that the positive charge Q1 is fixed and cannot be moved. It creates an electric field around itself. Now let's say that there is another positive charge Q2 at point A and the distance between the charges is r. Take a look at the picture on your screen. What will happen to the charge Q2? Well, Q2 will experience a force which equals to E1 times Q2. If we want to move Q2 closer to Q1, to the point B, we'll have to perform work. At that point, it is said that there is an electric potential difference between point A and B. Point A is at a lower potential. Now, performed work can be calculated using the formula on your screen. W equals to minus F times delta R, or minus E times Q times delta R, or even better yet, Q times delta V. Delta V is a potential difference between 2 points. The minus sign comes from the fact that we measure distance away from the charge Q1. Take a look at the picture below. If Q2 was negative, charges would attract. Therefore, moving Q2 away from Q1 will require work. Take a look at the picture below. Number of joules, or work, needed to move number of coulombs, or charge, is the potential difference between 2 points, and it equals to number of volts, or better yet, 1 joule per 1 coulomb equals to 1 volt. So far, we have defined potential difference between 2 points, but we haven't defined the potential of a point. We usually define a point with zero potential as one which is at an infinite distance from any charges that interest us. So how do we calculate the electrostatic potential created by a charge Q at a certain point? You can find the formula on your screen. Q is the charge that creates the electrostatic potential. Epsilon 0 is the permittivity of free space, and you can find the approximate value on your screen. Epsilon r is the relative permittivity of the material in which the charges are immersed. R is the distance from the charge Q. Of course, we can write this formula in another way using the Coulomb's constant. You can find that version also on your screen with the approximate value of the Coulomb's constant. Unit of electrostatic potential is volt. That should be it. Thank you for your time. Check out our YouTube channel for more lessons.